Okay, so let's continue. Today we will talk about exploratory data analysis for house sales. So this is a case study. So we're going to study one big data set. This is a big data set, and you will see momentarily. So let's get connected to the Colab. The data is actually stored right here, and if in these courses you are going to work with very large data set, that's how actually you assess those kind of data set. So you click this. So what you can do is something like that. So what you're going to do is you're going to click this button. That means add shortcut to drive. So that means you actually are going to save this file automatically into your Google Drive. Okay, so this is the way that you don't actually need to download that. You can just click this button. It will save to your Google Drive. Then everything you can just access through your Google Drive. So then I'm going to load the data. So this is and the way that you should be doing, you just add the shortcut to the drive. Then your Google Drive should also show up this file. So then what I'm going to do is I'm going to mount your Google Drive into with a Colab. So this is how you actually do it. So you can connect your Google Drive. I'm going to click that. Continue. So if you do that, you will see I have a drive here. Okay, so this is your My Drive. So this and actually has all the files that you have for the and for the in your Google Drive. So basically now your Colab can access all your files in your Google Drive. In particular, I have this file already mentioned here. It's called housesale.ftr. I'm going to read this using pandas. Okay, so there are two notebooks, and one is using the pandas, one is using the matplot, and also Seaborn. Those are like some packages that you actually need to learn, and you're going to learn it by yourself. Okay, so this is basically, this course is not introduction to those packages. So those packages you actually either learn it through the project, or you probably learn that in other courses. So I'm going to load this data set. This data is pretty large, so that's why it will take a little bit while to load. So you can see this data information. So you can see here we have a lot of data entries. So the data entry here is we have 64,000 entries. So this is a lot of entries, right? So that means there are about 165,000 house sales. I have a columns which is the features. These features I have almost like 1,800 features, and you can see how large of this data that we have is 2.2 gigabyte. That is really, really a lot of features, and it takes a lot of memory. So basically, this is not some like routine data that you actually work with, like in other courses. So this is very, very serious. And the data actually you are going to use is very, very big. So this gives you some guidance or idea what kind of data we are working with in this courses. You are always going to work, the data is that big. So just give you some indication. If you want to using something like ChatGPT or something other like and the large language model, they can help you at a certain level. but they cannot help you to do these kind of data analysis for such large data set. It's just because the data set is too big, those kind of large language model couldn't handle that for that kind of data set. So let's look at those kind of data shape and a couple examples. So this tells you the shape I already mentioned about. That's a lot of rows and a lot of columns. So let's look at the first 5 data. If you want to look at the first 5 data, you will say data.head. This is ID, this is address, this is sold price. So that's something that we want to predict. And that's sold on, the time that is sold on, this is a summary. So basically, if you go to like Raffing or Zillow, when you saw a house listing, there will be a summary for this houses, just tells you some basic informations of the houses. The type, year of build, whether it has a heating, whether it has a cooling, how many parking spaces that we have, whether it's a remodel, and a bunch of things, right? There are a lot of things. At the end, we have a zip code, right? So in total, we can see right here, we have 5 rows, and the amount of feature that we have is so many. That is 1,800 features. It cannot even list all of that. So this is way too much. And also, if we look some of the feature that we have, for example, all these features that we have, they are all empty. That means none. I don't even have a feature, right? So that means, and also probably these features are not that important, whether it's remodel or not. Doesn't like it's not important at all. So that means we are not going to using all the features that we have. So this is kind of like give you some idea. Although we have so many features, but we are not using all of that. In fact, we are only going to use very limited features. So for example, we're going to drop the columns that at least 30% value are null to simplify this EDA. So here's the way that we're going to do is we're going to sum all positive null values. So that means empty. I'm going to say, okay, so that's something I'm going to count. So you're going to see if those null value, and this is sum with all the columns that we have, can see is actually done like that. Okay, so this gives you some idea what kind of things that we so this is dot sum is actually sum like column wise. All right, so and then I'm going to keep the column that I will keep the columns. Sorry, I will remove the columns that 30% values are null. So that means, and what remains is at most 30% of nulls, right? So that means that is like, and most of the entries are filled. So if we do this, you can see here in fact we have a lot of like data that actually being, and the columns are being thrown away. Only have like very limited columns right now. All right, so then what I'm going to do is I'm going to basically replace those and drop all these columns that are most of nulls. So that means I only have work with 32 columns now. So with one single trick that we shrink our columns from 1800 into 32. Just that means I'm enforcing all my columns has to at least 30, at most 30% of nulls, right? At least 70% to be some values. But we are not throwing those entries. So we are just still keeping all these entries, but we just throw out most of the columns. So this already significantly shrinked our data. And to remind you, previously we have 2.2 gigabyte. After one trick, my data is only 40 megabyte. Okay, so this is like dramatically shrink. All right, so and you can see even with those 32 ones, probably not all the features are important. For example, ID. ID is something like it's some like random number. It's not that probably it's not that important. Okay, for example, like, and we also see something like something is not making sense. For example, this elementary school scores is actually an object, and my sold price is also an object. So the object is, you can think about everything as a string. It doesn't make any sense to think as your sold price as a string. If this is object, they will only consider this as categorical data, which is not true. And the same, this is not true for the elementary scores, because they are the scores from 1 to 9 and 1 to 10, but we need to assume 10 is better than 9, 9 is better than 8, and so on. And obviously, it has strong correlations that we can think about. If the higher the scores, the higher the house prices, right? So this is very, very, I would say, very, very intuitive. All right, so we have this elementary school scores. Here is what I'm going to do is I'm going to change this into integers, right? So the way that we're going to do is I'm going to change this into float first. So float, that means it's actually, I have something like if the score is 3, that will change into 3.0. After that, I may change into integer, so which is just 3. So because scores that we know it's all from 1 to 10, so that means actually just for that particular score it has to be 3 rather than 3.0. Same thing you work for, and you apply the same trick to the high school scores as well. All right, so, and you can see if we do this, and all the elementary scores is actually an integer, right? So that means the first one, it's actually 6, the second one, it's actually 9, and so on. And also, if we actually look this sold price here, this is actually a string. So that means I have a dollar sign of 2 million, which is not really what we want. We want to have a, like this to be has a numerical value, has a just has a 2 million. I don't have a comma here. I should just turn this into 2 million US dollar. So, I mean, the way that you have to be done is, I mean, all these like price and this tax assess values, tax amount, always have this dollar sign, always have a comma. So what you're going to do is you are going to say, I'm going to replace those dollar sign by empty. I'm going to remove all these comma to be empty. So all the symbol, they are going to replace that into like empty. And if it is not a number, I'm going to replace this as a, so sorry, I mean, if they have like these kind of like symbols, I'm going to replace this as a not numbers. So these are the way that actually you can replace all these string symbols and characters into some meaningful values. After we do this processing, I'm going to change this values prices into actually the float. So if we do this, you can see all my sold price will actually being like float right here. For example, this is $2 million dot zero. So this actually give you some idea. We have a number systems. We are, and all these things are being real values rather than an object. Object will not reflect any good informations. Only the actual numbers can give you some idea, because if it is object, it doesn't tell you $2 million is more than $1 million. They would just like and mechanically think $1 million and $2 million are some like independent categories if you just treat that as a string. And also, if we actually look this lot size, you can see this is kind of has a lot of interesting string, we have sometimes we have square feet, sometimes we have anchor, sometimes we have a noun. So that means you actually need to convert this area from string format to maybe square feet or anchors, and also to everything into the same unit, and change this into a float. So this gives you some idea. You actually have to do it, because otherwise you are compare apples versus pears. You cannot compare these two things. It has to be in the same unit. So that means you have to convert the unit. So what you do is you are going to say there are two things. One is total interior livable area. One is lot size. They all so both feature has these two issues. So that means you actually have to do this process. So what you do is, if this is anchors, you are going to multiply 43560. So this is the way to convert from anchors to square feet. So that means this gives you some idea. We're all going to talk about everything in terms of the square feet. So that means, and also we need to remove those comma. We also need to remove those dot. We need to remove this comma. We also need to remove this square feet and anchors. So that means you see the square feet and you squared anchors, you're going to replace by empties. Okay, so that's what you what you are going to get. So if you do this process, you check these things again, you actually will find your lot size becomes like that. So this becomes a float. And of course, if it is none, and this will be automatically replaced by not a number, it's a null value. All right. And also we can check some values for those numerical columns. You can see the minimum values, maximum values, and also some like medians, means, all these kind of informations. So the way you do is you say data describe. It will automatically get those numerical columns, and those numerical columns we are already processed. And what I'm going to do is I'm going to check some basic information. For example, this has a mean, has standard deviation, minimum, maximum. So you have to check something careful. For example, right here, this is a minimum and this is maximum. Total interior and a livable area, we only have 1 square feet. That doesn't make any sense, right? And this is 10 to the 8 square feet. That's a huge. And also this lot is actually 0. This lot is 10 to the 10th. So you can see the some like minimum value and the maximum value, it doesn't make any sense. And the text assessed value, this is just precisely equal to 0. Right? So this something is not making too much sense. And the list price is just $1. So obviously there's some error and outliers in these data entries. Same here, for those values is way too high, 10 to the 8th. Right? So what I'm going to do is, it's very likely those unreasonable values, and for example, the value is way too small or way too high, it could be an error. It could be and when people enter those values, and it's like an error. So this is totally possible. So what I'm going to do is, you actually need to fill out those houses whose living area is too small or too hard to simplify the visualization later. So this is give you some, although we have a 165,000 data entries, we're not going to use all of that. In fact, some of data entries obviously has an error, or has some outliers or something like that. We are not going to predict anything on the outliers. So we'll only predict some and the prices that in the normal range. So I will consider those data abnormal if my living area is less than 10 square feet, all my living area is more than 10 to the fourth in a square feet. Okay, so these are actually abnormal. I'm going to only work with the data that is considered normal. That means my living area has to be between 10 and 10 to the fourth, which is a very reasonable assumption here. So if we actually look how many data entries is abnormal, it has to happen to be 41,000. So that means out of 165,000, 41,000 data entries we consider is abnormal. So we are not going to work on these. So we're going to throw this away. Because if we include all these data, it will contaminate our data. So it will significantly lower my data's prediction and my model predictions and so abilities. So here my focus is those data is normal, considered to be normal. Okay, so then what we're going to do is we're going to check the histogram of the sold price. So this is something that our target we want to predict, right? So the first things that if we want to predict the sold price, it's better you make some like an histogram for that. So if we do some histogram for that, you will find out the data looks something like that, which is actually very and strange. Okay, so you can see there's a like two peak right here, so which is fine. I mean, it makes perfect sense if the sales price is within like 10 to the 5, 10 to 10 to the 7. So this is a normal range. However, there's some weird peak right here around 10 to the 3 to the 10 to the 4th, which doesn't make much sense, right? Because the house doesn't and it shouldn't be sold as like a couple thousands or even 10,000. So the most likely cases right here is because and the reason that we have this little peak is because when someone entered entries, they might mess up with the rental price and the versus sold price. So they might just list as the rental price, which is a couple thousands per month, as the sold price. So this is something that you have to keep in mind if you want to do some kind of modeling. It's very likely the best thing that you should be working is you need to throw out all these data is in these ranges, right? So that means there's something wrong with that, right? So that I mean give you additional idea if you want to do some like more data analysis before you apply any kind of modeling. The first thing that you should do is actually to fill out these kind of data, right? So this data is outlier and obviously is an error. And also we know house has a different types. For example, if we check the type here and to check the top 20 types that we have, you can see most of them is single family. There are several condos, there are several multi-families and vacant land, townhouses, and so on. And in many others, you can see we'll have a single family with a single space there, an apartment, and some like single family lot. There are a lot of like some like outliers of these types. And you can see these are like considered to be more complicated and the types is quite rare. So I was very likely, and what you can do is you can merge certain type into single family. Obviously, single family in this category should be merged into single family. And maybe 2-story or like 3-story you can merge together as well. And so on. And you can merge certain types into the other types. So that means you can build a map, right? And we're going to talk about this a little bit later. So, and you can set a bunch of rules right here, and a map map others into like the one that is more reasonable together. Because if you want to consider, the type, maybe the first couple, like 5 or 6 types, is more important. And everything else, they have so few numbers. I mean, it's probably likely they won't make much and different, and will not. I mean, in fact, it will not help you on building the models and making and predictions. It sometimes might be very likely give you the wrong answers and like deteriorate your accuracies of your models. So there are a lot of things that you need to think about if you have such kind of so many different categories of your types. How can I process the data like that? Okay, so in fact, I mean, in the most of cases, the one that you've been working with is single family, condo, multifamilies, and maybe townhouses. So let's just take these 4 different types. I'm going to plot this like so the price and see and how does that actually look like. And so you actually find out, okay, so right here I'm going to take the logarithm of the the price. So this is some trick or data transformations that being used all the time. In fact, I'm going to talk about it later of the courses. If like some and some like features or target is strictly positive and you suspect has a very long tail behavior, one way that you can do is you can take the logarithm of that, which to make sure they have a negative and a positive part, right? So, and you will find out, in fact, once you take the logarithm, this distribution is more likely to be a Gaussian. Previously, it might have like long tail. After you take the logarithm, you'll find out it's very likely they don't have the long tail anymore. And in fact, if you look this way, if you take the logarithm, you can see for townhouses is really like perfectly lined up with a Gaussian. Same with the condos, it looks and it really and it likes as a single peak of the Gaussians. And you can see most of that is being concentrated for the single family. There are a couple condos, there are a couple like townhouse and multifamily. But obviously, for the most part, it's single family. But also, you need to worry there's a little bit second peak right here. Just indicate it. I mean, this is actually and corresponding to the renter and a renting home. So basically, as once you do and when you do some like data processing, probably you need to remove those data entries because these data entries will not be predicted well. Okay, so another way is you probably need to do some like transformation of the data instead of you just work on one of that. So think about one way of measurement is sale price per living square. So and you can think about it's very natural to think about if you're and the living and interior like livable areas large, then of course your sold price is large. Right. So this is very important. But one way to think about whether this is expensive or not is you think about price per living square feet, right? So this just give you some good measures whether this is have a like high end or low end, and rather than just look at the sold price. So if we and here is a like simple like box plot versus and with the different types and the y-vert is the price per living square on different types. You can see and this is the distributions you can think about. You can see, and obviously the condo has slightly more price per living square, which is quite reason because condo is usually more expensive in terms of per square feet. And on the other hand, the multifamily is the cheapest, right? So this gives you some like distinction between the condos and the multifamilies, right? And a single family is right in the middle. So we also know the location actually and affect the price. some good location places might have like higher and the housing is like it's more expensive. Some areas not that good. It's quite and it's likely then and the prices will be cheaper. So if we actually get top 20 zip code, you're getting this like data and a data zip and a zip, you do the value count, you get like top 20 of that, you find the keys. What you can do is you do the similar things for those box count. Okay, so this is price per living square feet. You can see there's a dramatic different trend, and you can see right here, this area is probably the highest. Right, so that means this is a good area. On the other hand, this is probably a very bad area because the price per living square is significantly smaller, and then this is like, and the same here. So it's like and significantly cheaper. And also they're like in a very interesting trend with a different zip code. So this gives you idea if a zip code versus the sales price, and it has a significant correlation here. Some zip code has significantly and it could like significantly impact the housing prices by identify whether this like house is in the good location or not. Also, I mean, this is probably the end. It's the correlations. So these are also very important because I mean, in fact, we were going to talk about something like this in PCA. So and obviously we have 32 columns. You can like take all of that if you want, but say if you want say further reduce down to like even less and features, the one you should think about is if two features or a couple more features are highly correlated, you might think about, I don't want to use all of that. Maybe just take one or two out of three if all three are highly correlated. Okay, so the way, for example, right here, we have a sold price, list price, annual tax amount, and price per living square feet, elementary school scores, and high school scores. So they are all numerical value. You can do some correlations for those numerical values. You cannot do correlations on the categorical data set. You can't do it. So the one that you can see is what actually has a very strong correlations with the sold price. That's my target. It's actually the annual tax amount, right? So that has a correlation of 0.5. So that means if you want to predict that, in fact, this has a better effect than the list price. The list price, like I mean, the correlation is only 3 and 0.34. However, the annual tax amount, which has 0.5 correlations to the sold prices. And also within those features, we see elementary school scores and high school scores are highly correlated here. And the correlation is 0.48. So that indicates you might just, I mean, if you want to keep one of that, it's probably will not hurt the models a lot. Right? Because those like the correlations between the features. So that means elementary school scores and high school scores are highly correlated. So I mean, this is not very surprising because usually if a good high school scores, they usually in a good school district. Then with a good school district, the elementary school and the scores is also high as well. So this has a very strong correlations here. So that means if you want to prevent overfitting, you might just think about just keep one scores. You can keep elementary scores or you can keep high school scores. You can do some certain further analysis. I'm going to talk about that in the later of the courses, how to pick the right amount of features, and maybe just pick one of that, or maybe just pick 3 out of that. How do we pick that? If we have a 32, if we have a 1,000 features, how can we pick a good amount of features out of them? So, and obviously this is very, very important topics. So this is something that I and want to talk about today. In the meantime, I will suggest you to go back home to actually read this self-study materials. So this self-study materials is very important. I'm not going to talk about that in detail in the courses, but these are some skill sets you need to learn that. Okay, so these some packages, how you should be using that, how the way that and how to using those packages to do some simple data analysis, and which is turns out to be extremely useful and extremely helpful nowadays. All right, so that's it for that part.